Okay, so we're going to be looking at session number 2 in module 7 here. The last time we were together, we went through the details of creating a revision and updating a drawing for any changes that we would maybe make, and the reasons for making those changes or having a revision on a drawing is, for instance, if we released it to production and we realized something didn't work quite right, or we wanted to make a change to improve it, then we have to actually document that the revision occurred, so that, in the event somebody ever looks back, they kind of know what happened there. And that's very typical out in industry. You want to document kind of the history of any changes that are created. So you got kind of a look at that. Now what we're going to do is, if we remember, I'm sorry, not from session 1, I want to look at the practice problem. So what we did last time was the module 7 practice problem -1. So we had 3 drawings that we looked at: the base plate, the bearing, and the collar, and we made some changes to it. Okay, so we updated those. So now those updated drawings, the revisions that we created, which were increasing the holes on a couple of them, making the counterbore deeper, stuff like that. I think we put some tolerances on the bores. But now what we want to do is we want to use those updated files to create an assembly. Okay, so underneath my camera right now, this is how we would put those 3 parts together. And we had looked briefly at the beginning of chapter 11 in our AutoCAD book, where we saw kind of the pictorial or the isometric of these parts that would go together. And then we were working on the last time those 3 parts. So on each one of these parts, we did some updates. So with those updated files now, we're going to put the assembly together, and then also add the 2 screws that are going to kind of keep everything in place. Okay, so we're going to be creating an assembly drawing. Okay, now we haven't made assembly drawings yet. Up until this point, we've been just working on detail drawings, and a detail drawing is one individual part. What are all of the dimensions of the features so that it can be created. So when it comes to its final form here, now it's going to fit with those other elements so that it's going to function appropriately. Okay, so now we want to show this drawing of everything together. Okay, and that's called an assembly drawing. Now, elements that we see on assembly drawings, first of all, are going to be, we have a standard drawing border that it's put on. So in this case, I have an A-size border. Okay, and then you're going to notice that we bring the parts together so we can see how they fit together relative to one another. Now, in this case, we only have one view here. These parts are pretty simplistic, and if we kind of remember them, they were symmetrical parts. So if we would do a side view, we're not really going to get a whole lot from it. Okay, so we instead put a section view in here because we want to be able to see the inside parts so that we can identify the most internal parts, if you would. And the most internal parts would be our hardware or our screws that are holding everything together. We want to see those as parts in the place where they're going to be. So many times in an assembly, we do create sections through so we can see those internal parts. Okay, just like dimensioning, we cannot balloon to something that is hidden. Okay, we can't. We have to be able to see it and point to the actual part. Okay, just like we can't dimension to a hidden feature, we can't balloon, and that's what these guys are called, balloon to a hidden feature. So balloons are going to be on here, and these balloons you're going to notice have a number associated with them. Okay, those correspond to the little chart that we see down here. Now, in manufacturing, we call this a bill of material, or sometimes referred to as a BOM or a BOM. Okay, like somebody will say, well, how many parts are on the BOM, or how many parts are on the bill of material? This is our bill of material. Now, different companies will structure this bill of material differently. All right, I kind of kept it simple for us. You're going to notice our item number is going to correspond to the balloon. So item number 1 pointing here is going to be our base plate. Okay, and then over on the right in the last column, it tells us how many, what is the quantity of items that we need to create this assembly. So for that base plate, we just need 1 part. Okay, then you're going to notice our item number 2. It's pointing right here. That is our bearing. Okay, and our bearing, we need 1 of those as well. Item number 3 is the collar. That's up on the top here, and we need 1 of those. And then finally, we need 2 cap screws, and you're going to see those right here. Okay. You don't have to balloon when you have multiples. You don't have to balloon each and every one. Okay. And actually, we only want to do one because if there was more views, which you can have those in more complex assemblies that have more parts, typically you will have more than one view available. But we don't want to balloon it in one place, then change something about it, and then forget where the balloons are. Just like when we dimension, we only dimension features in one view. If we do dimension them somewhere else, we have to make them reference. Okay. And only we add reference drawings if it adds adds clarity to the drawing. Now, when we look at the title block, really everything is filled in exactly the same, except for material. We don't leave that blank because there isn't a specific material. These parts could all be made out of different material. So we just put non-applicable or NA. Okay, that's what we put in there. Our date, our scale, still the same, whatever the name of our, or the description of our assembly is, and then part number. I created a random part number, okay? And that's a column you would most often see added here in the bill of material because we're not saving things as part numbers. I'm just going to leave that off. But when you do some more projects, for instance, in your next CAD classes, and then also coming up probably in your second year with me, we do that. Okay. But right now we're just getting the feel for it. We just want to kind of go through the process, and quite honestly, in AutoCAD, that's enough to do. So we're gonna focus on creating this assembly drawing tonight. Okay. So just kind of an introduction. Now, another assembly drawing that I wanted to show you, I do have a PowerPoint from our textbook, but then as I was looking at it, all I was looking at was how the assemblies that they're showing are for different industries, and they end up not really reflecting how we do it in our ANSI standard. So that's why I wanted to show good examples so that you don't have to try to decipher what's right and what's wrong on the drawings that are in the book. The book is a great resource, but they are a resource for architectural, construction, all industries. And this particular industry, in that particular chapter, they really don't do a great job of what the ANSI standards are. The other one that I wanted to show you is a drawing that in the engineering design projects course, we have the students create an arbor press, okay? And it's actually one of the assemblies in your TechDr book. Let's see. I think it's in that same chapter that we're looking at, actually. I'm pretty sure it is. The arbor press is in here. Sorry. Maybe I'm wrong. I guess I'm wrong. I guess it must be in a different chapter, but it is out of this book, the Arbor Press. And this is an assembly that has more parts on it. Obviously, there's more than 3. You're going to notice that we have a longer list here of items. I'll zoom in for a little bit and we'll kind of go around here. So over here, you're going to notice that we have the item number, which is going to correspond to the balloons that we see here. And then you're going to notice we have a part number associated with it, the description, and then the quantity. Chris, did you find it? Oh, what page? 692. I think I didn't go quite far enough, maybe. Yeah, you know what? I know why I don't see it, because I probably pulled the page out of my book and did a scan of it. I tend to do that, so that's okay. So if you go to page 692 in your book, I just can't show you underneath my camera, in the tech drafting book, you will see then the Arbor Press assembly there. Thank you. Thank you. So our students, one of the projects we did in there earlier this term is they assembled using SolidWorks, and they created all of the detailed parts. They created the assembly here, and then they had to create a standard assembly drawing. So you're going to notice that we have a front view, left side view, and then a top view. And through those views, you're going to notice that we have to then identify each one of the parts in our bill of material. Okay. Now, something that you'll notice about an assembly drawing is that we don't put all the hidden lines in here. It would be kind of crazy town, especially when you get into drawings that assemblies that have more parts like this one. There would be just lines on lines on lines. And then it just becomes just, what is what. So we always remove the hidden lines in an assembly drawing, okay? So that's why you can kind of see then if we don't have the hidden lines there and we need to either add clarity, then we start sectioning so that we can look at more internal parts. In this case, we were able to get at all of the internal or all of the parts without doing a section. So, so that's acceptable. It's not like you have to do a section all the time, but if you have those internal parts that you want to see, then you have to do that. So yeah, so we when you're working with a parametric software like SolidWorks, because you have, for instance, an isometric view like this, it's always nice to put that up in the corner. AutoCAD, we don't have that because we're drawing in 2D and we're just drawing the views, okay? But as we have software like that, it's nice to add clarity and kind of give a nice picture so that especially, I mean, for us too, but for people who might be viewing this that aren't as reading blueprint savvy, if you would, then they have another view that they can kind of go on to. So this is what assembly drawings, you know, this is what we're trying to represent, show how the parts are going to fit together, what the parts are. And so when somebody is putting it together, they know where things go relative to one another. Okay. So any questions kind of as we just kind of look here? You'll get multiple opportunities to put assemblies together in classes that are coming up. So just wanted to kind of give you a nice overview. Okay, so let's then, I am going to go back over underneath, and we are going to be putting together our assembly. So like I said, we are going to be taking those revised parts from our Module 7 Practice Problems 1. So you're going to notice, and the reason I say revised parts, because remember last time when we kind of figured out how we wanted to tolerance the depth of that bore on the bearing so that our collar would only seat on, you know, it's landing right here. So you'll notice that there's a gap here. If you don't use the revised versions, there's not going to be a gap, right? Remember how that dimension was the same? So I'll kind of know. So make sure you do the revised one. That's going to be my clue. So what we're going to do, the process is we're going to bring in these parts one at a time. We're going to get rid of the parts of the drawing that we don't need, which means some of the views are going to go, the dimensions are going to go off and such. We're going to kind of clean it up if you would. And then we're going to arrange it as we see here so that we can see how all these parts go together. We're going to do the hatch function. So I'll be practicing that and kind of utilizing it on an assembly form. We'll talk about rules associated with that. And then we're going to be creating our bill of materials. So you can see how in AutoCAD we use a table to do that. Okay. So I am going to go over to AutoCAD. Actually, before I go over to AutoCAD, just make sure, remember this was the Module 7 Practice Problems 1. Don't use the files that are downloaded, okay? You want to use the ones that you revise. So hopefully you've done those revisions already. If not, no problem. Just watch and take in the information of the process that we're going to go through. And once you have those updated, then you can go ahead and do the assembly. But I wouldn't do the assembly until you have the revised pieces, because otherwise you're going to have to do stuff over. So it's these 3 parts, okay? And then I'm going to go over to practice problem 2. And you're going to notice that this is where the cap screw part is. This is a DWG drawing. This is going to be the other part you want to download and put somewhere that you can recall it, because this is going to be what we're going to be pulling in for the 2 cap screws. For those who are virtual, the shaft support assembly PDF is right here in the practice problems -2. And this is that guide that I have in hard copy underneath my camera. Okay. So I'll just give you a chance to locate those 3 drawings and the cap screw, get those together. And then what we're going to do is we are going to start a new drawing using a WCTC inch template. Okay, when you come into AutoCAD here, so we have like a nice fresh blank slate. Okay. Now, I'm going to be going back and forth underneath my camera. Okay. And again, we're going to be creating this view right here. Okay. So the first part, I usually pull parts into an assembly that makes sense of how I'm actually going to probably put it together. Okay. So I'm going to start with my base plate here. So I'm going to go over to AutoCAD. And now that I have just a blank drawing here, I need to insert that file as a block. Okay. So to do that, just like we insert a border into a part, we're now going to be inserting the part into this file. So we're going to go to Insert, and then we're going to arrow down on Insert and go down to Blocks from Library. And then this dialog box is going to come up, okay? We're going to arrow down, and we're going to say Browse Block Libraries. And all we're doing is we're browsing to or navigating to where those files are. So my drawings I have in my directory, Mechanical Design, I have a Tech Drafting folder, and then I have Module Assignments, and I have it under Module 7. Okay, so you want to navigate to wherever your revised versions are. Now, I'm going to grab my base plate, and that's going to be this one right here. And yes, it is going to have the border on it, the dimensions on it. We're pulling that all in, okay? And you'll see what we do with that in just a second. So I'm going to say Open. And now you're going to notice that it populates on the left-hand side here in that dialog box. Remember, this is not a click and drag. This is a click, click, okay? So I'm going to left click on it in the box, and then I'm going to just move my cursor over, and it's going to be on my cursor, okay? Mine has construction lines. I'm going to delete those anyway, not a big deal if yours does too. And I'm just going to left click anywhere on the screen. Now it's going to ask me, what is the scale, okay? And I just want to put in a scale of 1:1, always 1:1 when we're pulling this stuff in, okay? Borders are different. Borders, we have to fit around something. Parts, we want them to be to the size that we drew them to, so 1:1, okay? Everybody get that? All right. Now, if you click on here, or if you just kind of hover over the top, notice that it's a block as one that came in, just like when we pull our border in, but now the whole drawing is a single block. We need to explode that. So we need to go back to the home menu, and right underneath our eraser is the explode function, okay? It's like this box with the sides that are kind of split apart. So we're going to explode, and you can click on any entity in there, and it's going to select the whole thing, and just hit enter. And what it does is it goes back, if you would, one level. So you'll notice that all of these dimensions and entities are separate now, but if I hover over my border, it's still intact. And that's okay because you know, it's kind of like it's at that drawing level now, okay, when I exploded it once. Now, the only view that I need for my assembly drawing is going to be the front view, if you would, of our base plate. So we can delete everything else, and that's what we're going to do. So I'm going to do the erase or delete. So I'm going to erase, and I'm going to left click starting down in my lower right hand corner, and I'm just going to select over everything I can, and I'm going to hit enter. And then I am just going to focus on leaving this view right here. So I'm going to do erase again, and I'm going to get rid of all of these lines, okay? And then I'm going to erase that dimension. Now, you could, and some people do this, you could leave all the dimensions there and just hide them. Like you could go up to our layers here and just hide different things. Remember, that's data that is being saved in that file, okay? And if you're not going to use it anyway, I say delete it, get it out of there, just because. So that's how I handle that. Some people, like I said, will turn layers on and off, and then it's in the background. I just feel like the file is unnecessarily large if you do that. If you delete everything out, then it's a nice clean drawing in geometry. Okay, so I've got that part in here. Now I'm going to do my next part. So if I go back underneath, the next part I'm going to add is going to be that bearing, okay? So I'm going to go back into AutoCAD here. I'm going to go up to Insert, Blocks from Library. And oh, it's already open. Sorry, I could have just gone right over here. And then Browse Block Libraries. And then I'm going to, probably will go back to that same directory. You shouldn't have to navigate this time. And we just want to find the bearing, okay? And again, it's going to be that whole drawing with the border and everything. It's going to insert it. I'm going to left click and left click to place it. And my scale, I'm going to enter 1, enter, okay? Now here again, this is a block. We need to explode it. So I'm going to go back to home. I'm going to go to explode, just anywhere on that drawing, and then enter. Now in this case, I'm going to zoom in here a little bit. In this case, I only want this right side view, okay? So everything else can go. So I'm going to erase. I'm going to kind of left click and go underneath. When you start and you left click and you start your window in the bottom right going up or left, you get this dash around that box, and that means that anything touching that box is going to be deleted, okay? And so I do want that. When you start in the upper right and you go down, then whatever is in there has to be fully in the box. So I'm just going to kind of go around here, and I'm going to erase these items with windows so I can kind of grab as much as possible. Let's see, still got those A's there. Okay, and all I want to do is just get rid of all of the dimensions. You can leave the hatching, the center lines, you know, that kind of thing, anything with this view. Okay, so now once you have all those removed, okay, and you just have the area that you need, now what we got to do is orient it and place it on our base plate. So first of all, I got to rotate this 90 degrees. So I'm going to go up to the rotate function. I'm going to select or window around that entire view, hit enter, and the base position can be anywhere. I'm just going to place it on that drawing. And then now you could either use your ortho and just move down and it would go 90 degrees, or you'll notice that you can enter in an angle as well. So I'm just going to go down with my ortho and then left click, kind of like drag it if you would, and then it's there. Or like I said, you can do the angle. Now what I want to do is I want to move this so that it is positioned on my base plate. So I'm going to go to my move function. I'm going to window again around my part, enter, and I'm going to 3 places you could go. You could either go at the intersection here at the bottom of that counterbore hole, the bottom of the through hole, or the other counterbore hole, because they're going to line up with those corresponding places on the base plate. So any one of those 3 you can grab. I'm going to grab in the middle just because it's the middle. I'm going to turn my ortho off. And then I'm going to find that intersection where that center line is with the part. Okay, so it's sitting right on top, and you're going to notice that everything lines up nicely. Okay, now is a good time to probably do a save because I've pulled in a couple things and done some things I really don't want to do again. So I'm going to do a save as. And here you want to navigate, probably is going to the same directory that you pulled those parts out of. And you just want to call this the, what is this called? The shaft support assembly. Okay. And I use ASSY as my abbreviation. Okay. All right. Then we got one more part, which is our collar. And then we have to pull in our screws. So since we have this dialog box open, we can just arrow down, browse block libraries. And this time we're going to pull in the collar. Say open. Left click, and then pull it in. I'm going to kind of pan down and left click. And then my scale is going to be 1. Once you have it in, you're going to explode. And then we're going to get rid of the parts that we don't need. So if we go back underneath here, we're going to tip that on its side, and we only need that side view, if you would, that has the section through it. So if I go back to AutoCAD, I'm going to erase all of this stuff. And then that dimension and that dimension. Yeah. And again, you could hide things here. That would be fine. But again, I feel, why save all that stuff if you don't have to? Okay, but it wouldn't be terrible to do that. Okay, so then now what I want to do is I want to rotate this so that it's 90 degrees from where it's at. So I'm going to do the rotate command, select that view, turn my ortho on, and then just grab, you know, a point and then go down, or do a negative 90 degrees so that it rotates clockwise instead of counterclockwise. Okay. Now, this one, I'm going to do just a little bit differently. Okay. And what I'm going to do is I'm going to move this. I'm going to select the entire file, but I'm going to go at the bottom of that center line, and then I'm going to put it on the bottom of this center line. Okay, so I'm not mating them just yet because I want the centers to be lined up first, and then I'm going to zoom in, and I'm going to select this again and move this so that this surface, okay, this surface, because remember when we were designing, we want this surface to be on that surface, okay? So I kind of did it in two moves, if you would, okay? And now you'll notice that if you're using the parts that you revised, you have this gap, all right? And that is by design. We intended that when we did our dimensioning the last time we were together, okay? So good time to do a quick save so that we don't have to redo that. And then the last two parts that the last part, but we're going to bring it in twice, is going to be our cap screw. So I'm going to go down to Browse Block Libraries. I have my cap screw in that same directory. You might have to go to your downloads to grab it if you downloaded it from Canvas. And you're just going to select it and you're going to say open. And we're going to do a click, zoom out a little bit, and a click. And it's going to be a 1 scale factor. And then I'm going to do it one more time. Click. You don't have to go to the Browse Block Libraries. You just want to click it in twice. Okay. And then here again, it's a block. So we've got to explode each one of them. And then we just want to get rid of the dimensions that are here. So I'm going to delete all the notes. Hardware, this is considered what we call a standard hardware, okay? I shouldn't say never, I can't speak for every company that's out there, but most companies I worked for never created drawings for standard hardware, okay? You specify it, you have to create a little drawing for it so that you can balloon it and represent it, but you'll never have, I shouldn't say never, you most likely will not have to ever make a detailed drawing for it, okay? I just had the dimensions on there for reference, okay? So now we have these parts in, and then now we're going to move these into their spot. So I'm going to do move, select the first cap screw, and what I'm going to do is hit enter. I'm going to grab the intersection right here underneath the head where it would be seated in the counter board. Do you see that where the center line is? So I'll do that for this one. I'm going to move again, select this one, grab that intersection, and then move it to the bottom of the counter board. Okay. So I'll give you a second to kind of get that going. And then now we can close the dialog box for insert. Okay. Any questions so far? Just kind of, and really, if you would have more parts, you would consider it, you would continue to insert, and you would explode, get rid of what you don't need, and then place, and then insert, explode, place, that kind of thing. Okay, you kind of keep doing that. Once we have all our parts in place, we're going to peek back at our guide. Okay, you'll notice that I don't see horizontal lines going through my screws, okay? I don't see, the horizontal lines going through here as well. So what we need to do is we need to clean this up. We also need to, you'll notice that we have hatching on each one of these parts, okay? The hatching on each one of the parts, and I'm going to zoom in here so that you can see it. I'd like everybody's attention, okay? Because these are things that are the ANSI standard. So when I have parts touching each other, everybody see this? You'll notice that it's not the same hatch, okay? We pick a different hatch because we want to show that it's a different part. So the hatch in the base plate is evenly spaced and it's going at, 45-degree angle here, okay? Then you're going to notice that the hatch that I chose for the bearing, I've got 2 that are closer together, then there's a bigger space, and then 2 that are closer together and a bigger space. And notice that the direction of the hatch is going in the opposite direction. So when these 2 surfaces touch one another, the hatches are not in the same direction and they're not the same style, okay? ANSI standard. That is by design. So I don't want you going in, setting hatch once, and then just hatching everything. Otherwise, it's going to look like it's all the same part, okay? And then lastly, when we look up here, we switch the direction again for what it was up against. Now, sometimes parts are going to, this is what you try to always make happen, okay? Because these parts are stacked on top of each other. We don't have them sectioned relative to something that might be coming in on the side here. Sometimes when you have multiple parts coming together, this doesn't work out perfectly, but then what you do is you make sure that either the spacing between the hatch or the hatch is different or it looks different, even if you have to go in the same angle, okay? So just want to make sure that hatching is there. When it's on one part, it's one hatch, but when you have multiple parts on an assembly, the hatch needs to be different on parts that are up against each other, okay, or are touching each other. Now, the other thing you're going to notice here, we did not hatch the fasteners. Like if we think about a slice going through here and we're slicing right through the middle, you might be like, well, why didn't you hatch the fasteners? The rule about hatching is number one, we don't hatch fasteners ever. And we never hatch the most internal piece. Sometimes that might be a key, okay, like on the inside of a shaft, okay, or something like that. It might be just a little or a pin, okay? We don't hatch those things. So notice that we didn't hatch hardware or fasteners or the most internal piece, okay, most internal piece. All right, so now we need to try to get all of our line work correct. So let's go back over here to AutoCAD. First thing that I'm going to do is I'm going to select the hatching on both of these, and I'm just going to hit the delete button. So I'm just kind of grabbing them and then selecting them and hitting delete because I know I'm going to be changing it, so I'm not going to be using the hatch that's there. The next thing that I'm going to do is on our base plate, that was not a sectioned view. So we need to change the hidden lines that are there to visible lines, right? Because when we hatch through there, or when we section through there, we are going to need to have visible lines here and here, here and here, and then the visible lines, those are going to be the threads that are going through. I'll show you what we do there. So I'm going to go back over here. So I'm going to change, and I'm just going to select by grips. I'm going to select this first line, second line, and these are just the holes that are going through. I'm going to select them all at once. All of these are going to go to the object line layer. So I'm going to go up to my layers and I'm going to switch it to object. Okay. And just hit escape. And then now you're going to notice that they are object lines. I don't have my line widths on, so I'm going to add those. It looks better. Okay. So I've got those in place. The next thing I want to do is I want to deal with my fasteners here. Okay. If we look at the guide, okay, you're going to notice that we don't have any of those horizontal lines going through. So let's look at those first, okay? So I'm going to go back over here, and anywhere there's a horizontal line, we are going to trim that out. Now, when we placed our bearing on top of our base plate, there are two lines here. There's a horizontal line in the bearing, the bottom of the bearing, and there's a horizontal line, if you would, the top of our base plate. It's good practice not to have overlapping lines, okay? So what I'm going to do first is I'm going to delete the line, not for the base plate, because that one runs the entire length. I want to delete the line that is just the bottom of the bearing. So to do that, I'm going to hit the erase command. I'm going to do a short little horizontal box. So I'm going to left click up here, left, and I want to start in the upper left, lower right, because I only want that one line to be what I'm going to delete and has to be completely inside of there. So I'm going to left click when I get that. Notice that down here in my dialog box, only one line was found, and that's exactly what I wanted. I just wanted that horizontal line along the bottom of that bearing. And now I'm going to hit enter, and it's gone, okay? We didn't see anything happen because there's the other line there from the top of that base plate, okay? So now when I delete, or when I trim away the line in between here, I only have to trim away one line. If you trim and you don't get the line to remove, it's because there was two lines there that you have to trim away. Does that make sense? Okay. We just don't see them because they're right on top of each other. So now I'm just going to use the trim command, and I'm going to get rid of the inside. And now notice to where the thread is, I have to get that little part too. Okay, so there's the larger from the center line and then between the threads. Okay, those two lines represent, remember, the major and the minor diameter of the threaded features. Okay, so then I want to do that down here as well. This line, and then the little one between the threads. Okay, then I'm going to go over to the other side, do that very same thing. This one, and then between the threads. This one, and between the threads. Then I'm going to go up to where the head of our cap screw is. And we just got to get rid of these two lines here. That's the back side of that counter bore. Okay. Oopsie. And then the same thing here and here. So we don't have those going across. And then here as well, there is a line at the bottom of our cap screw that is this on the line that's on the bottom of the counter bore. So I'm going to do that same thing. I'm going to erase, and I am going to just grab this line right here. And if you grab the whole counter bore, then you'll just have to either put the line back in because it grabbed both of them. But if you strategically place your window so that it only selects what is inside of there, just get the bottom of that. And then you're like, well, how do I know? Well, if we hover over this, there is only one item that it selects. Okay. So, all right. So now we kind of have it partially done. The next thing we're going to notice is that there's a couple lines going vertically here. Okay. So we have to make sure that we have the correct ones. So first of all, let's look at our bearing plate. So I'm going to zoom out here. Here's my full fastener. I'm going to zoom in on the part where it goes through that bearing. Okay. Now remember, we increased the size of this clearance hole to be 1/32 larger than the actual fastener, right? If you didn't do that in that side view, you're not seeing two lines right now. Okay. You need to see two lines. All right. And that means that you did it correctly. That's how I know you did the revision. Okay. When we put the assembly together, we see these things. So I want to make sure that you see these outside lines. And if you do, perfect. We're leaving it in there. That's the clearance hole, a 32nd larger than what the fastener was. These two lines, the inner white lines, this is the major diameter over the threads on our fastener. Okay. So that's going to be 2 3/8 of an inch because that's 0.375 fastener. Then on the inside, our hidden line, this is going to be representing the root diameter or the minor diameter or the tap drill size, okay, that you would make that to, okay? So that's going to be representing there. So that part is good. Now, when we get down here, we have extra lines, okay? Now, the first set of extra lines that we have are going to be, or two sets of extra lines on either side are going to be the threads that were in our base plate. So all we're going to do is we're going to get rid of those because we're going to let our fastener represent the threads because they're there, okay? So all I'm going to do is I'm going to get rid of these two lines right here. Do you see how I have those on there? Okay. Enter. So there's a hidden line to the outside representing the threads in the plate. That one goes. But then there's one on top of the 3/4 inch fastener. So I'm going to delete that one with there. Okay. All right. So what you should be left with, you should only have one line that is representing the length of the threads on that fastener. And then you have two hidden lines just in the inside of each one of those that is going to run the length of the fastener as well on the base plate. Does that make sense to everybody? Okay. So you don't have those extra hidden lines. We're going to do that very same thing over on the other one. Okay. So we get to do it twice. So I'm going to start where we did last time. And up here, this looks good. So we've got the offset for the clearance holes. And then now we want to erase the two hidden lines here and the two hidden lines here. Okay. Enter. All right. So that looks like it's cleaned up. Chris. Yep.
rule kind of just say that if there are threads in that situation, even though they're on the one feature and the fastener, the rule is if the threads aren't fastener only.
Yes, and it's just because if we go in here, there were those extra lines. When we make our drawing, okay, even if we go underneath here, if I would have those really close extra lines that were in there, oopsie, the extra lines that were in there, it would be like really thick and black right here and right here. And it doesn't represent correctly. And since the threads are really they are threading into the threaded hole, we just represent it once with the threads on the fastener. Does that make sense? Okay. Yeah. When programs like SolidWorks do this, they do this for you. Yeah, you're gonna like okay, I hope you're having fun in AutoCAD. Okay, I don't want to put AutoCAD down, but it is a much more manual process because we're having to create each and every line and kind of look at each and every one of the elements here, where in programs like SolidWorks, Creo, the parametric, where you're modeling and then you create your drawings from the models. And I don't want to say they automatically do it because knowing these rules and doing it in this fashion, number one, you understand what orthographic projection is. And if you don't set things up correctly in SolidWorks or those programs, then it's going to not make things correctly. And then you have to know how to actually fix them. Okay. So there are things. So that's why we start here. We get our fundamentals here. It's kind of like we're walking before we're running. Okay. So I don't want it to sound like, oh, other software is easier, or they're going to do it automatically, or you don't need to know this. Like I've said, actually, we had an advisory committee meeting today earlier. And I always like to just make sure I've been out of industry for a while, but that doesn't mean I don't know. I don't think I'm irrelevant. Okay. Um, I know I'm I know I'm not. Actually, my husband is a manufacturing engineer, so I kind of know what's going on in the industry. So anyway, and I also do some training out in industry as well, and I've done that for many years. But anyway, so the work of an advisory committee is really to guide and advise our programs to make sure that they are up to date to what's going on out in industry and what graduates need to know as they're, expecting to be hired. And one of the things was I asked about AutoCAD, like, hey, we all use an AutoCAD yet? Or you at least, have it out there? And every company said yes. Every company said it might not be our main tool for everything, but we have it for history. We have it for creating DXFs. We have it for creating files for our laser or, different types of things like that. So yeah, it is an important. So not only is it still used out in industry, but it also provides us this fundamental foundational skills to learn and understand how these are created. Okay, enough of that, little bit of a sidebar. All right, so now we've got that fastener up in there. Let's now look in this area right here. We want to clean up the extra lines that we have up there. So if I go back to AutoCAD and I zoom out here a little bit, this is the area that I want to look at. Now, if I click on this middle line here, this is the line going all the way across on the top of our bearing. We don't need that extra line in there. So I'm going to hit enter. Okay. And the only other two extra lines that we have, okay, are going to be the horizontal, or I'm sorry, the vertical line here on our collar and our vertical line here on our collar. So we're going to delete those out. And again, they are literally just line to line on top there. If you don't delete them, I'm not going to know. But you guys are just going to have to sleep at night knowing that you didn't erase those, those duplicate lines. So I'm just saying, you're gonna have to look in the mirror in the morning. I don't know. I'm just saying, I don't know if I want to be you. I know I deleted my lines. All right. Okay. So that looks like now that we've everything like cleaned up, if you would. Now we're ready to add our hatching. Okay. So we're going to change actually, let's do a quick save. Again, we don't want to lose anything that we don't want to redo. So I'm going to go down now. I'm going to go on my layer for my X hatch, and we're going to click the hatch command, which is down below the ellipse command. Okay. So we're going to click on that, and we've done this before. Now we've got a new ribbon that shows up, and the standard ANSI 31 is going to be selected. That's the default. And we'll use that one first. So we can leave that selected. And then what we're going to do is we're going to hover over in the areas that need hatch on the base plate. And as I'm hatching here, what I'm really kind of looking for is how does the scale of the hatching look to me? Does it look really close? Does it look really far apart? I think it looks perfect, actually. It's a good size. And the angle right now is 0 coming in, and the scale is 1. So we're going to leave it just like this. We're going to leave this just like that. So I've got a little above the through hole here on the left and right sides of our fasteners, and then a little bit at the bottom of the through hole on the right-hand side. Okay, so in those 1, 2, 3, 4, 5, 6 areas. Okay, now this will also let you know if you did not put your corners together, or if you have overlaps, or there's openings anywhere, it won't hatch it. It'll give you an error, or it'll escape outside of the boundaries, and you're gonna be like, what? Why is it, you know, trying to hatch so far away? And it's because the geometry isn't closed. Okay, and that's where also, if you have lines that are overlapping, it gets confused. Okay, so so we have to make sure we've got good geometry and single lines only. All right, so as long as that looks good, you want to hit the green check mark or enter, and now we have that one done. Now we're going to hatch the areas that represent our bearing. So X hatch is still on. We're going to go back into our hatch. Now, this is what I'm going to tell you you will not do, okay? You're not going to leave what you had on for the last one, and I just want to show you why. If I start hatching with that very same hatch, do you see how it just doesn't look right? Just doesn't look right. And it almost looks like you have to try to distinguish between part to part. Okay, we want the hatching to help us with that. Okay, now let's say you do this and I hit okay, and you get it back, and Kelly says, okay, minus 432 points because you're not supposed to put hatching in the same direction. Okay, well, now I got to go back. I've got to open this up, and I've got to change it. So if you select the hatch here, it's going to select it. So I just left clicked on it. And then my hatch dialog box is going to come up. And all you have to do is you want to change it to a different style. Now you're going to notice that up here, these are not the only styles we have. You can arrow down here. Please do not use brick or cork or anything. We are not in the construction trades, okay? They look kind of cool. I get it. But we are boring, and we are, you know, mechanical. So we use these first top 2 lines, and that's as far as we go. Okay. The other ones are, you know, those are for the fancy people. But so now all we want to do, I'm going to go out on a limb. I'm going to say ANSI 32. I'm going to go that one. And you're going to notice now the pattern is different. Now, let's say we had multiple parts coming together and you're like, this is about as good as I can get. This would be okay. But to be even better, now we want to change the angle over on the right-hand side here to the right of by layer. We want to change that 90 degrees. Right now it's 0. It's 45, but it's considered the 0 degree, the start point. If we hit 90, it changes it then 90 degrees. You could put it at another angle. You could say, for instance, you could say, for instance, 60 degrees. Okay, let's see, did it go? Do it again. Let me change that to 60, enter. I don't really like it. Do you see how it's like, doesn't look awesome. Okay, 90 is definitely better. So you never use vertical or horizontal, ever, okay, ever. But so 45, 90, 0, those are the good ones, okay? All right, so that's our second one. Once we have that in there and that looks good, we're gonna say okay, all right? Then we're gonna do our third one. So now since this direction changed and we changed our hatch type, we're now gonna hatch again on the collar, and it's gonna go back to the standard, the ANSI 31, which is fine. And you could leave it just like this, okay? Because then you alternated back. But we don't wanna just be okay. We wanna be awesome. So what I would do here is I would change the scale. Okay, so again, it doesn't look like it's this like part of the bottom. So I'm gonna say the scale from 1 to 0.75. Okay, I'm just gonna make it a little closer together. And now if I like squint my eyes and I glance, you're gonna notice that you now have 3 separate parts. Do you see that? Okay, and then we've got all of the hatching where it's coming together, going in opposite directions. So it's distinctly different parts. Okay, and then again, we do not hatch any fasteners ever. Okay, we do not hatch any fasteners ever. So this is as far as we go with the hatching. So let's do a quick save. So good. All right, let's compare it back to our drawing guide. And I think we're looking pretty good. Okay. So if I zoom out, the next things that we want to do is we need to bring in our border, okay? Because then that'll help us set up what our text size is, okay? So I am going to actually stop the recording here so that we don't have like a hour-and-a-half long recording. I'm going to stop it here, and then we'll start again when we bring in our border and add the other items here.